Right. We're going to start? Yes. Okay, so hi everyone. Hi people online. Today we have a presentation by Daniela Barrientos. Daniela is a postdoc from the Evolution and Information of Galaxies with Patricio. So today she's going to talk and teach us about how we can optimize a Python code. Bye.
Okay. Thanks, Vale. So we will continue.
Yes.
Yes. So today I brought this notebook, kind of to show the code. So trying to find out what's taking more time, more memory, and to try to make your code more efficient. I have like a lot of modules and stuff here and there. I won't go deep into any of them because of the sake of time. But I put a lot of links and stuff in the notebooks of that so that you can later go through it and just check what's afterwards. So why is profiling really needed? You're just running your computer and then that's fine. But sometimes you need to do more longer runs or process a lot of data, or you need to run a simulation, or I don't know, make a pipeline to process data. So then is when you need to maybe put a little more. And I'm probably, I guess, of ways in which you can measure how long code runs. Some of them use NumPy arrays, which are made to be fast. Then you get like an improvement in the time that it takes to make the submission. You can also do it in an iterative way, because sometimes code for reasons on your computer, like the or stuff like that to do an exploration of how fast your code runs so that you can do this. So let's do some simple comparisons of different implementations of some code and try to guess which will run faster. So these are like the simplest things that happen in life. So for example, there's different words, and then I'm gonna run these three cells and we have to guess which one of them is the fastest one. I don't know if you have already a guess. So as you can see, and so on, up to a million integers. And we're gonna use these 4 5 minutes. So first we're gonna just iteratively append numbers, is like x to the second power. On an empty list, we're gonna just append them one by one with a for list. Then we're gonna use a for loop using the Python range command, and we're gonna do the same, but using NumPy range command. Then we're gonna use NumPy ranges and just directly square them. And then we're gonna use this math function with the lambda, this lambda functionality to do the same thing with the arranged NumPy. So as you can guess, probably NumPy is gonna be like everything that uses NumPy is always quicker than using native Python. And then we can check. So first two are pretty much the same. Then we have this list composition thing that's a little more expensive on time. Oh, and I'm using iteration, so that's why it takes longer. So yeah, it took longer to run, but actually per run, it's so all of the things that are just NumPy with NumPy, if you operate vectors within each other, that's always going to be faster than just doing a loop of things using lists with Python. But yeah, but there's, for example, this option that you may have not known. So we're gonna check. On an aggregated time takes the longest because this is the and secondly you have this sleeping time taking some time of this over.
I have a question. So, total time is the whole time it's used in that operation or whatever it's running. But for Pericol is how one process from that.
Yes. So what? Yes. So one time calling the calc big number thing takes seconds. But so that's the time it takes to multiply 5 to. It's not multiply. It's doing the power of 5 to the billion or whatever. And then because here this tells you that in total the function, so build, list, and sleep, calls within it 32 functions. So it's 25 times the call big number, and then there's all the other things that it calls within. And this is the that I can use to check line per line instead of like method data. So in here, there's less lines in because it only checks the lines in this function, which is the one I'm calling.
Okay.
So here, this will also give me the same information. It will tell me that it's build list, it's the building list, the one that takes the longer instead of like this sleeping time. Yeah. So depending on what you're doing, you might want to check process like method by method, or you might want to check like which. called a profiler or live profiler and give it like a whole Python, like a .py script, and it will also give you uh, the information. I think in that case, it outputs like a file that gives you this information. That's fine. Yeah. So at the ask, yeah. What this does is that the information that you get from this module, it will go through to the cache memory. So instead of like calling it 25 directly, and then you skip calling it multiple times. So if we run now, time it will do the normal Fibonacci, which has 1,004 function calls, just 4 primitive ones, which yeah, because this is a nested run. But then the second time I do this, it will just use the cache data that I already have stored. So then it's just 3 function calls, and it takes yeah, it's like 0 seconds, but yeah, basically it goes one um, yeah, it's 0.00, I think 3 or something like that. Mhm. Yeah, so that's one of the questions. So yeah, with these results, relation background. So in this case, I'm gonna implement this function to calculate the center of mass in different ways, and we're gonna just compute just Python-based code with lists and for loops, which you're gonna guess is like the slowest version that you can do. And we're gonna print, that's what I, and we're gonna time it. So, as you can see here, okay, yeah, this is not a lot of particles. You have like 2.86 seconds, which is what it takes to calculate the center of mass. But then, as I said before, you can use libraries like NumPy or big improvement because things are optimized to make these calculations. There's a big improvement, especially if you want to do this for many particles or many galaxies at a time. But you can go even faster with some tricks. And here's, I think, the last thing I'm going to show. And there's this library called Numba. I don't know if any of you are familiar with it. But what Numba does is yeah, in Python you compile everything. It does its own thing over there. But you can do other implementations. What Numba does is that it does a thing called JIT, which is just in time Python, native Python computation of the center of mass. But we're gonna add this decorator with JIT. And what it's gonna do is that it's going to do this just-in-time compilation of the code, and this should give you an improvement in performance. So I will run this, I will time it. And so the first time it runs, it takes actually longer than what it takes for NumPy because it compiles the your function. Faster than using NumPy. So yeah, this is what you can like fix for everything. Number you can really mix with some more complicated like data structure. Yeah, there's other options that I won't go through in this because we don't have time, but there's like multi-threading, for example, especially for like these for loops that you can just like do one at a time, different processes. There's also a library called Theano, which handles mathematical like computations really well and really fast. And you can also check, for example, other Python compilers that do this thing a different way. So you can, because Python, most of check where the bottlenecks are and
Okay. Thank you, Daniela. That was very useful. Do we have any questions from the people, the audience? No?
I have a question.
Yeah.
Really sure part with the cache, if you want to like delete the cache, can you do it during like the same like session, like without going and rerunning the kernel?
yeah, there's yeah. I think yeah. You don't want that simply.
Yeah. I was going to ask you, maybe we can have, if people are interested, we can have a second session where you teach us multi-threading, which I think
Yeah, I
is-
got
Yeah, no, I think it's very useful, at least for us simulators to have somehow to estimate the time it will take to run, because sometimes we have to run stuff and then we have to leave, and then it's like, oh, I have to wait for this, and it will take, I don't know, maybe more time than I had. And I think the only thing we get taught is like the start time with like start and stop, and then making that's timing. But I find you guys interested. So I do have a question on number. So it works with only Python based things. So because you said pandas, since it has underlying C, it might not.
I don't think it's the fact that it has underlying C, it's just the kind of data structure that Panda builds. There's some things that that don't mix well.
I'm thinking, for example, with the structure of dictionaries that have dictionaries within dictionaries, like whether it could be useful as well to
Yeah, I
do
think
something about it.
I think native Python structures should work well with Namba.
And Number, you have to basically install it in your environment, or
I don't remember because like way prior, or if it's already like when you do like Conda Python from but yeah, you can also just pip install it.
Yeah.
It should.
Any more questions? No? Okay, if not, we thank Daniela again. I could say something to the people online.
Yeah, thank you. Anyone is watching online, thank you so much for joining. And if you're watching YouTube, subscribe and we see
Hit
you
the
next-
bell for notification.
Thank you very much.